Hi, in this tutorial we are going to start with k-means clustering algorithm. So the first point about k-means clustering algorithm is that it is a partitional clustering algorithm. It is a partitional clustering algorithm. We have already studied about partitional clustering where we divide the given set of objects into some partitions. Right, so in this tutorial we will cover all the important things to consider about k-means clustering, which includes the gradient descent and some optimization criteria, time complexity, and the advantages and disadvantages of k-means clustering. So first thing is we need to understand what is k-means clustering. So in k-means clustering algorithm, we are given some value of k. So let's say we are considering the value of k as 3 in this tutorial. So given a value of k, so this is actually given to us. What we do is we divide the given objects into k number of clusters. So I'm going to write here k clusters. So let's suppose we are given some data objects and I'm going to represent them using a set. So let's say we have a set of objects which goes from x1, x2, and let's say we have m number of objects. So I'm going to write it something like this. So this is the data points or the objects, or sometimes it is also known as instances, right? So we are given some instances or objects which are m number of objects. So m represents the number of objects in my data set. So after we will run the k-means clustering algorithm on this data objects, it will convert them into k clusters. So what will be the output after running this k-means clustering algorithm? It will give us the number of outputs as clusters, and we are going to represent clusters with the name S. So the clusters will go from S1, S2 till k number of clusters, right? So we use S to represent the cluster name. So if we have k clusters, the output will be the k number of clusters. All right, so this is what the k-means clustering algorithm do, which is essentially to divide the whole data objects into some given k, which will give us the k number of clusters. So let's see how this algorithm works and how can we actually generate these k clusters. So the next step, first of all, what I'm going to do is I'm going to just draw these points. Let's say we are given some points. Let's say we are given some data objects and I'm going to draw them here, right? I'm just going to draw, let's say this is the given data set that we have, right? These are the points that we are given and we are given k as 3. All right, so the first iteration, in the first iteration, there will be some steps in the first iteration, and we are going to just recursively do those steps again and again in the further iterations to improve the clustering algorithm or to optimize the clustering algorithm. So what is the step 1 in this algorithm? So how do we actually start the clustering algorithm, right? So we are given this this whole data set, these objects. The step 1 is to choose the k points randomly, right? So I'm going to write here, choose k points randomly. All right, so in this data set, what we're going to do is the first step is to choose the k points randomly. So in our case, you can see the value of k is 3. So let's say I choose one point as this one. This is our first point, let's say, right? Let's say this is our second point, and or let's say I choose this one as the second point, and we are just choosing any random value, right? Let's choose this one as the third point. So we have chosen 3 points according to the step 1. So what is step 2? In step 2, what we do is we try to find out the distance between the points that we have chosen with respect to other points, and if the point is near to it, or if the distance is smaller, we say that it belongs to a same cluster. So what we do is we calculate the distances, and assigns them to a cluster, or to a chosen point. So we have chosen a point. You can see these are the 3 points. Now what we will do is we will try to calculate the distances and we will assign them to this cluster. So let's say I will assign this point to this one and this point to this one, and similarly this will go here, and this point is also assigned here, and similarly I will assign this point, all these points which are near to it, to this one, right? The next point is this one, so you can see this is near to it, so I will assign these points to here. You can see like this, and these will also go to blue point, right? And the last one is this one, so we will calculate the distances of these points, and since they were near to this point, we will just assign them to this point. So after doing this assignment, what we observed is that we have obtained 3 clusters, right? You can see that when we have assigned it, we have obtained these three clusters, which are something like this. Alright, so the question is, how do we calculate this distance between a point and the point that we have chosen? So we have already studied the Euclidean distance. I've already taught this in a previous video, and I've given the link to this video in the description below, and also to the whole machine learning playlist, so you can check that out also. So we use Euclidean distance to find the distance from one point, from between the 2 points, right? So it was used as a dissimilarity measure. We know that Euclidean distance was used for the dissimilarity measure, right? So we calculate the distances and we assign them to a chosen point or a cluster. So this was our step 2. So the question is, since now we have obtained these clusters, so will the k-means clustering algorithm stop and return with these 3 clusters? The answer is no, because at this point it is not optimized. So at this point, after iteration 1, it is not optimized. So how can we say that it is optimized or not? We need to find out some criteria. We have to set up some criteria using which we can say that at this iteration the whole clusters are optimized and the whole points and the distances between them are now optimized, right? So there should be some optimization criteria. So now here I am going to write the first of all, let me define what is Euclidean distance. The formula for Euclidean distances goes from s equals to 1 summation n, and inside it we write xis, xjs, where s belongs to the cluster number, right? Then we do the square, and finally we do the square root of this, right? So this will give me the Euclidean distance, and I can use this to calculate the distance, and we will assign them to a chosen point. Now we have to set up some optimization criteria. We will have to set up some optimization criteria. So what is this optimization criteria? Now we have to understand this. This is a very important part of the k-means algorithm. Now we have seen that at this point also we have obtained three clusters, but it may happen that some of the points that are assigned to these clusters should not actually belong to these clusters. So we have to optimize this whole iteration. We will have to keep optimizing it, and at every iteration we try to optimize it. So there should be some criteria where we should where the k-means clustering algorithm should stop, and basically the optimization criteria that we are going to use is known as WCSS, which is within cluster squared distance, right? Sum squared. I will write that it is within cluster sum squared. Alright, so what is this WCSS? It is the within cluster sum squared distances. So how do we calculate it? So first of all, what we do is we calculate the distance of the points and the point that we have chosen. We will calculate those distances and we will do the square sum. We will square them and we will add them, and then we will do this for all these clusters. We will do it for this cluster and for this cluster and for this cluster, and finally we will add them up, right? So it will be, first we will add, we will find out the sum squared. Sum squared is given by xi minus mu I mod whole square, right? Where mu I is the center of these clusters. These clusters are basically S is represented by the cluster center, right? So we represent a cluster by its cluster center, which is given by mu I. So we have the cluster center and xi represents the points that are there, right? The data objects. We calculate the square sum distances and we square them until and unless x belongs to S, right? Now this is for a single cluster. Since we have k number of clusters, we will sum this also, and we will run this from s equals I equals to 1 till k, right? So what essentially we are doing is we are actually setting up a criteria which we will minimize, right? So you can think this of as the remember in the linear regression tutorial, what we do is we define a cost function, a hypothesis function, and we have to set up some optimization criteria, right, to optimize the hypothesis function. Now what we do is we use the cost function to find out the cost of each and every, for each and every parameters we calculate the cost, and finally we find out the minimum cost. And after finding and how do we find the minimum cost is by using gradient descent. So wherever the gradient descent will converge, we will say that the cost is minimum at that point, and we will use this to calculate the hypothesis function and we will get the exact result. So similar to that, we are going to do this in this tutorial. We are also going to we are going to calculate the sum square distances from each and every point to the center of the cluster. We will square them up, and then for each cluster we will first calculate this sum squared, and then finally we will add them up. And now finally when we have added it, so you can see in the first iteration we have obtained these clusters. So we will calculate the sum square distances for this particular iteration, and then we will plot it on the graph. So we will plot it on the graph, and in the next iteration what we will do is we will try to find out the step 3. We will do the step 3, right? So this step 3 will be able to do the recursion where we will move to step 1, and in this manner we will be able to move to some more iterations, right? So step 1 is to choose the k points randomly, then we will calculate the distance and assign them to a chosen point, and then after doing this we will calculate the optimization criteria or within cluster sum square distance, and we will plot it on the graph. And then what we will do is we will recalculate or recompute cluster centers, right? So at this point you can see these are the clusters that we have obtained. Now we will compute the cluster center. You can see the center of this cluster is around here, and the center of this cluster is around here, and the center of this cluster is around here. So we recompute the cluster centers. So instead of choosing the k points randomly, what we do is we reassign these points that we have chosen in the first iteration, and we reassign them to the cluster center in the next step. And then again we will calculate the distances and we will assign it to these chosen centers, right? So this is the third step where we say recompute cluster centers and move to step 1. So now after completing the step 3, which is to recompute the cluster centers, we will move to the step 1. We will again choose the k points randomly. We will not choose the k points randomly now because we are actually recomputing the cluster centers. So now we are going to choose the cluster centers here. So after the first iteration, the clusters are going to be something like this, right? These are my clusters and these are the cluster centers which we have recomputed. And now what we'll do is we will calculate the distances of the points with respect to these centers according to step 2, right? We will calculate the distance. More specifically, it is going to be the Euclidean distance. We will calculate the Euclidean distance and we will assign them to a chosen point, which will be something like this. And let's say there was a point here which is now a part of this cluster, right? So a reassignment take place at each and every iteration. Remember that at each iteration we calculate the optimization criteria, which is the within cluster sum squared. It is similar to the cost function, right? It is similar to the not by formula wise, by logically it is similar to cost function. We calculate the cost at each and every iteration of this k-means clustering algorithm, right? We have chosen this as the optimization criteria. So what we will do is we will keep optimizing it, and basically by optimizing, we mean that we are going to minimize this distance, which is the sum squared distance. So the next step is to find the convergence of the k-means clustering algorithm. So when we calculate the optimization criteria at each and every iteration, it is generally observed that the k-means clustering algorithm will keep on decreasing, right? Something like this. It will start going down. It might not reach the global optimum, right? So let's say this is the global minima here. This one is the global minima, and this one is the local minima. So the k-means algorithm at each and every iteration, when we recompute the cluster centers and we will recalculate the distances, and when we will recalculate the distances, the sum squared distance, which is this one, it is also going to change. And it is observed that after each and every iteration, this distance or this cost goes or converges downwards, right? It decreases and it keeps on decreasing, and it will reach to some optimum. It cannot, it is not necessary that it will reach the global optimum, but one thing is sure, that this algorithm will keep on decreasing. It will reach the local optimum, and that's the main reason why we call this as a limitation of this algorithm, because in gradient descent algorithm also we have studied that this is the basic limitation, that the global optimum is not reached, right? So at this point, when we have reached the local optimum, we say that the slope at this point is 0. So basically, if I will differentiate this function, I will get the slope, which is the dy by dx, and this slope will be equal to 0, and this will help me in calculating the convergence, right? So if we will calculate this optimization criteria, and if at some step the differentiation of this optimum or the optimization criteria gets equal to 0, I will say that the k-means clustering algorithm will stop and it will return the clusters, right? So now let me write the convergence criteria, something like this. So what is the convergence criteria? First of all, we will have to do the optimization. We will have to write the optimization criteria, which was equal to sum of goes from xi minus mu I. So instead of mu I am going to write a, and here I will write the square. So a is also the cluster center. I've just used some other representation, or let's not create some confusion here. Let's say it is mu I square only. Alright, so here you can see that this was our optimization criteria, which was the sum squared distance, right? This was the result. Now what we have to do is we have to differentiate it, and when we try to differentiate it, and we know that the convergence criteria says that after differentiating this whole term, if it is equal to 0, it means that it will converge, and at that point we're going to stop the k-means clustering algorithm and we will return with the obtained cluster. So let's differentiate this. On differentiation, 2 will come here, so it will become 2xi, and summation is also here, then minus summation of this will be 2 mu I, right? So 2 will come here and 2xi minus 2 mu I, and we will give the sums to both of them respectively, right? So now it will become 2 mu xi equal to 2 sigma mu I. We will cancel 2, and since there are m objects in my given example, we will write summation of mu I because there are m centers. So I'm going to write this one as m mu I, right? So since each and every object, we have m objects, or m can be the members of a particular cluster center, or say cluster center, or only the cluster, right? So let's say this is the mu I, and here let's say we have a member m j of a particular cluster. So basically what I've done is I have just written summation mu I equals to mj mu I, because we have m number of objects and these objects should be the members of the cluster center that we have chosen, right? So that's why I've written mj here. And now we will compute the cluster center equal to mj will go down in the denominator, and we will write sigma of xi. Now this equation that we have got, Now, whenever the center of any cluster will be equal to 1 upon mj, where j is the member of a particular cluster, and we will we will find out the sum of all the objects. If this will be equal, we can say that now the convergence criteria is met. So at this point I can say that the algorithm is converging, right? Since it is converging, we can stop the algorithm, we can stop the k-means algorithm, and after stopping we will return the obtained clusters that we have. So this is the k-means clustering algorithm. The first step, I will just give a summary of what we have done, because we have done a lot of things in here. The first step is that we chose the k points randomly. We calculate the Euclidean distance and assign them to the chosen point, and in this manner we obtain a particular clusters. Now we move to the optimization criteria, which is the sum squared within cluster, and we calculate this distance with respect to each cluster, and then we add them up. Then we will move to the step 3, which is to recompute the cluster centers. We will again recalculate the cluster centers, and then again we will move to the first step. We will again recalculate the distances. You can see in this step we are recalculating the distances, and we will assign them to the chosen point. And then again we are going to calculate the sum squared distance. It is generally observed that from iteration to iteration, or after several iterations, the algorithm will start decreasing, and at some step this will the slope will be equal to 0, so the differentiation is equal to 0. So the convergence criteria, the criteria is the convergence criteria just basically says that at this point we will stop the k-means algorithm when the slope is 0, right? So whenever this sum squared distance is equal to 0 or about 0, we will say that now we have reached an optimum solution, and at that step we will the k-means clustering algorithm will stop, and it will return the clusters as the output, which is in this form, right? And the optimum criteria, the convergence criteria, what it does is we will just differentiate it. At this step we are just differentiating it. This is the optimization criteria, which is the sum squared within cluster, right? I'm just going to write here sum squared. We use this, we differentiate, and after differentiating we have come up with this equation. So whenever the mu I, which is the cluster center, is equal to 1 upon mj summation of xi, it means that the algorithm has now converged, and at that point we will stop and return with this output, which is the k number of clusters. Alright, so now we have done the k-means clustering algorithm. So let's try to understand the time complexity of this algorithm. The time complexity of this algorithm. So there are various steps, and for each and every step we can calculate the time complexity. So in the first step, when we were trying to calculate the Euclidean distance for each center, so when we were calculating the distance or the Euclidean distance for each object, it takes big O of n time, right? So where n is the dimensionality of the vectors. Alright, what else? We were also reassigning the clusters. We were recomputing the cluster centers, recomputing the clusters, and it will basically take big O of k m time, right? So k is the number of clusters and m is the number of objects. The third one is to compute the centers, right? So we will have to compute the cluster centers. You can see in this step, in the step 3 we were computing the cluster center. So let's see how much time will it take. it will take big O of mn, where m is the number of objects and n is the dimensionality of vectors, right? The last one is the, assuming that these two steps are done for t iterations, right? We are doing all these steps 1, 2 and 3 for t number of iterations, and we know that after each and every iteration the algorithm will start decreasing monotonically. So after t iterations we can actually come up with t, k, m and time complexity. So this is going to be the actual time complexity that the k-means algorithm will take to compute the clusters or the partitions given the m objects. Alright, so we have covered the time complexity now. Now let's see what are the advantages and some disadvantages of the k-means clustering algorithm. So the advantage is it is fast, it is a robust algorithm, it is a very fast algorithm because it converges, it always converges, right? And it converges very fast. So it is also efficient, it is relatively efficient, and we know that the time complexity is big O of k, m, n, and for t iterations, right? So t, k, m, n. And the last point is that when we will give it, we will supply it with best data set. If we have a very good data set that is optimized for this algorithm, and basically best data set means that it is clearly separated into clusters, right? So if the data is separated, it works very efficiently. Now let's take a look at the disadvantages of using k-means clustering algorithm. What are the disadvantages? So the first disadvantage is that it requires us to specify the number of cluster centers, right? We will have to specify explicitly number of clusters, right? Which is k number of clusters. So we will have to supply it with some value, and this is a disadvantage. The second disadvantage is the hard assignment of data points, hard assignment of data points to the cluster, data points to the cluster. And we know that we use Euclidean distance to calculate or compute the or assign the data points to a particular cluster. So it basically is an hard assignment because it takes a lot of time for doing that. And the very important one, the important disadvantage is that it may converge to some local optimum, right? So we may have some global optimum, but it will just miss that. It will go to the local optimum. And we have seen that this is also a disadvantage of using gradient descent, right? So these are the disadvantages of using k-means clustering algorithm. So that's all for this tutorial. Thanks for watching.